Hey, good morning. Can someone tell what time are we planning to start this session? Sorry, can you all hear me?
Yeah, sir, here.
Okay, fantastic. So are we waiting for something, or when is the session plan we are planning to start?
So as per agenda, it will start actually for 11.
Okay.
But technical session start from 12, sir.
Okay, so I see. Okay, so in that case, I'm just looking at the technical sessions. Probably I will disconnect now and join back at 12.
Yeah,
Is that okay?
so can you, okay.
Yeah, so sorry, we were about to ask something.
So you got agenda PDF file?
Yeah, I got that. I didn't go fully gone through. Yeah, I now remember that it's something the technical sessions.
Yeah. So in the agenda PDF file, they even based on your name and project title, they schedule the time.
Okay.
Hello. Hello, good morning, everyone. Am I audible to everyone?
Hey, good morning. Yes.
Good morning.
Good morning. Good morning. I think some more people have to join the conference. Hope everyone is fine.
Yes, we're fine.
Yeah. Yeah, audible. How about others? How about others? Some more people have to join the conference. Hope everyone is fine. Okay, everyone mute from their side, please. Let me start the conference. I ask everyone to mute from their side. Let me start the conference. I ask everyone to mute from their side. Let me start the conference. Good morning. Am I audible to everyone? Good morning, one and all present here. Am I audible? And voice is clear now?
Yes, ma'am, audible.
Yeah, now everyone is audible. Now everyone can unmute, no? Could you hear me? I think everyone can unmute now. Everyone check now. Yeah, now you can able to speak now. What about the others?
Yes, madam.
Yes, ma'am.
It's audible as well as you can speak now.
Yes.
Okay, then let me start the conference. Now you can mute from your side. Yeah. So good morning, everyone. Let me start the conference. I welcome you all to the IOT and Intelligent Apps 2020, organized by Institute of Engineering Research and Publication, IFERP. And when we IFERP, Institute for Engineering Research and Publication, is one of the world's largest non-profitable professional association operating under Technorate Research and Development Association, TRADA, meant for research and development in the field of engineering, science, and technology. IFERP is a paramount body which has brought technical revolution and sustainable development in the field of engineering, science, and technology. And this is the conference organized by the end of 2020, December 4th, as a part of its IoT effort to facilitate the progress of the field of IoT and intelligent applications, as well as expedite the advancement of this technology. IFERP has arrived on the following theme for its conference on IoT and intelligent apps, with the theme of breaking down the complexities of IoT technology, elucidating its vast and largely untapped potential, and promoting its foray into the future. And IoT and intelligent apps will be a key factor for designing our near global future. We are in appropriate time to host this conference, build a cohesive environment to catalyze the research developments on the recent trends towards the IoT and intelligent apps. I would like to welcome our honorable keynote speaker, Dr. Maurice Ezra, who is the Deputy Director, Institute of Postgraduate Studies and Research, University Tunku Abdul Rahman, Kanjong, Malaysia, for joining us even during this pandemic situation and imparting their expertise with us. I would also take this opportunity to welcome all our presenters from abroad and India who had spared their valuable time in enlightening us with their latest research studies. So I would like to welcome all the attendees, participants, those who registered for presentation in joining us today. Now I request our eminent keynote, Dr. Maurice Ezra, to come forward to deliver his speech.
Hi, a big hello to everyone. I am Dr. Morris, Deputy Director for the Institute of Postgraduate Studies and Research, University Tunku Abdul Rahman, Malaysia. I would like to take this opportunity to thank Institute for Engineering, Research and Publication for inviting me as the keynote speaker for the 30th World Conference on Applied Science, Engineering and Technology. I would like to congratulate IFERP on organizing the same. Today, I would like to talk on Internet of Things, ride the next innovation wave. Internet of Things is getting very popular these days. This is part of the Industrial Revolution 4.0 as well. This is all about automation. So what is this Internet of Things? And how does it help in the automation? So we'll be looking into that. And also we'll talk something about the big data, the analytics behind it, and what we do in our university. So this diagram actually shows what is Internet of Things. There are two sets of two diagrams. One shows a very general picture on the left. Okay, so here it is about anything, any device, anyone, anybody, any service, any business, any path, any network, any place, anywhere, and anytime, any context. So basically we use internet to connect all of these things, whether it is the human being or the business or industry or using any network or any path. We are not limited to Wi-Fi or 3G or 4G or 5G type of networks. You are on any network, you should be able to connect and then communicate with the servers. And on the right, you'll see that what are the types of businesses that can basically use this IoT. Healthcare can use it, building energy management, machinery, logistics, devices, and retail business as well. So let's look into some of these things in brief. Okay, machinery. Machineries can be controlled from a remote place using computers. The feedback is given by sensors which we mount on the machinery. Be whatever it is. Okay, and same goes for logistics. Logistics is all these packages. Okay, for example, you order food, you can track live on a map where the food delivery person is, and you can get ready to receive the package. And also goes Hi, a big hello to everyone. Cholesterol measurement devices and so on. There are a lot of these healthcare devices, fall indicator and so on. So these can actually transfer
சரி. ஆடியோ இப்போ நம்ம கொஞ்ச நேரம் முன்னாடி பார்த்தோம் மேடம். ஆடியோ லீவ் கம்ப்யூட்டர் ஆடியோ ஆப்ஷன் ஆடியோ கனெக்ட்னு இருக்கு. அவங்களே சிஸ்டமும் கனெக்ட் ஆயிடுச்சு. இப்பயும் பிரச்சனை பண்ணிருக்காங்க. சாப்பிட்டு தான் வந்தேன்.
I hope everyone is audible now. Is it audible?
Yes.
Actually, sorry for the interruption. We apologize for that because of here a rainy condition, we face a network issue. So now, shall we go ahead with the keynote speech? Now we'll go ahead with the keynote speech where we face the network issue.
Hi, a big hello climate change, and during the climate change, the specs, the box like what they provide in the software immediately. Maybe every 3 months they can issue a new version, and your software will keep on updating as long as you keep subscribing. Okay, and next is IoT security. Because of all these data that is being transmitted back and forth from your computer to other servers at the back, security becomes a big concern. Whether people can see what you are typing on the document or not, whether Microsoft records all those things or not, becomes a significant concern for many organizations. And also a lot of companies do invest in this security apparatus, be it software or hardware, and this is expected to slow down the IoT adoption, because a lot of them may be worried about the data that will be stolen and which might be passed on to their competitors. Next is virtual and augmented reality will add a new dimension to the IoT for both consumer and enterprise application. So again, there is a lot of VR and AR things that are coming up. So you can see online, there are so many AR videos being posted on YouTube and other websites. Where you can wear the specs, the box-like thing which you wear, and then you can actually see what's happening from the other side of the world. You don't have to be at that particular place. For example, you want to have a tour of the White House. Yeah, it might be possible by sitting in India. You don't have to go there. You can just walk through the whole White House using this type of, or you want to visit Niagara Falls, you can just go and visit by just sitting in India. You don't have to travel. Especially during this pandemic time, when people are not able to travel, these things help people to just relax and de-stress themselves. Okay.
Sir,
and again, we come back to the massive volumes of time series data, and IoT analytics will be a specialized category and discipline. This is on the education part. The previous one is more on the business and so on. This is on the education. The next one is on the automobile sector. 10% of the drivers will use new auto accessories which are connected to the internet. Today, I think you all know there are music entertainment systems which you fix inside the car, which basically can and mostly some of them are Android devices. They can connect to the internet and download or stream music. I think in India you have Spotify, you have Wing, Netflix, and so on. They can stream data through the online connection which your car provides. Okay, either you can have a separate SIM card, or you can hook up the entertainment system to your mobile phone as a hotspot, and then you can stream videos, music to your car. And also companies like Tesla, they do upgrade their car software over the air, same like what they do for your phones. Okay, you can go and update your apps and everything which are there for Tesla using this. Your car is connected, always connected to the internet. And you will also find that a lot of companies will now report numbers of connected products. Okay, for example, Tesla may no longer, forget about Tesla. Maybe take a company like car company like Toyota. Toyota can now tell people, I have 1 million cars which are connected through the network to the internet service, through which so what happens here is through which data can be streamed back. For example, if Spotify or Netflix finds that 1 million Toyota cars is a valuable connectivity, they can have some special package for transmitting video or audio music to the cars which are connected through Toyota servers. Okay, so Toyota by that gains some value, because Toyota provides some business to Netflix, and so Toyota's value in the market value increases. This is on the business side. Okay, next is the World Economic Forum predictions for 2025. 92% believe that 10% of the people will wear clothes connected to the internet. To be honest, just a day back, I saw while browsing the internet, they have come out with a mask. I think now mask is getting famous because of the pandemic. I saw a mask with a LED display, which is connected to an app to your phone. And you can display messages through the app, and it will be displaying some advertisement, or you can put some funny messages on your mask. Okay, so it is already there. It's just a matter of time where people may wear, I think youngsters love to wear t-shirts with some slogan on that. So maybe it's more attractive to them to have different slogans every day. Okay, so just one t-shirt, they can have different slogans every day. It looks like they are wearing different t-shirts. Okay, so it's something which may happen, and it has started happening as well. And then 82.9, 82% believe that 1 trillion sensors will. The sensors can be, it can be your ECG sensor which is there on your watch. And again, about 70% believe that 50% of the internet traffic to homes will go to appliances and devices. As I had told earlier, your washing machines, your air conditioners, all can be connected to the internet. And then about 85% of the population, world population, believe that 10% of the reading class will be connected to the internet, which is already happening. Google came out with the Google glasses. Now Apple is trying to come out with the glass as well. I think they are privacy concerns, because people can take pictures without you knowing that they are taking pictures. Okay, so there was some privacy concern, and moreover, Google just came out as a proof of concept idea, and hence it was taken out. And now there are companies which are looking into how to come out with that type of devices. And the effect of IoT data analytics, it has a lot of effects. Okay, one is disruptive technologies can bring change which incumbents cannot deal or cope with. For example, in India, one of the important disruptive technology was Ola and Uber, by which taxi drivers lost the market overnight. Auto drivers lost the market overnight, and all of them had to jump into that new technology model where the cost is already fixed. When you book a taxi or an auto, the cost is fixed. Okay, so you cannot now argue or bargain over what is shown in the meter, whether the meter is running fast or slow. All those things need not be worried about, but it is something which brought some cheer to the general public, but it actually did not bring a cheer to the auto driver community or the taxi driver community, because they lost a certain amount of revenue on them. Okay, and then economies of scale are evaporating. Like for example, Amazon. So you don't have to store everything in your warehouse. Amazon can store it for you. All you need to do is put up a shop, just connect between these warehouses, and you take the order, and the warehouse will do the shipping. So those days, we used to buy cheap things from those big shops where they used to buy in large volumes, and the price is usually down. Okay, so those things are now evaporating, and then businesses are because of that, businesses are becoming nimble and flexible. You can't sell this, you switch to another one, which is very easy. Those days it was not very easy. You set up a shop to sell textiles, and suddenly you find that textile is not selling well. You want to sell something else, maybe vessels or whatever it is. It was very difficult. So now it is all there. It's just only online. You go and create more web pages selling some utensils. Yeah, you can do that. So businesses are nimble and flexible, and no one can assume traditional basis of competitive advantage will last. For example, those days when you got off from the railway station, you have to pick up the auto or the taxi which was parked there, and you have to accept the rate which they which they proposed. No way you can argue on that. But nowadays, things have changed. So here, you just get on from the station, you book a Uber or Ola, and then you take it. So it's the taxi drivers and the auto drivers cannot think that, yeah, I can depend on this type of crowd. It is not happening as well. Okay, so this is the traditional versus modern way of doing business. Okay, so things keep changing. We have moved to digital, and Uber also can give you some suggestions to take a taxi or an auto, or maybe if you are a regular user of Uber, Uber may think of giving you a small discount when you book the next time. Okay, which may not happen if you are booking the same taxi driver 100 times as well. Okay, so that's something, and this is how the traditional base, Nokia can never depend on the traditional base. People thought people will be buying Nokia, but then when smartphones appeared, people shifted their base because smartphones offered more than what people asked for, and they all moved it. Type of data analytics, confirmatory data analytics, predictive data analytics, and text analysis. Okay, so the first one is descriptive statistics. So here you provide a simple summary about the sample and about the observations that have been made. Maybe you look at the data, as I told you earlier, you just look at today's data and say, hey, the traffic is, it looks like the traffic is heavy there. How do you do that? You just simply just observe the data where number of vehicles are standing in the particular road. You can tell, yeah, there is a traffic jam. Next is exploratory data analysis. And this is an approach to analyze data sets to summarize their main characteristics, often with visual methods. Maybe we just say for one whole day, the data set for one whole load. Whether the exploratory data analysis which you did earlier actually is correct. Okay, so quantifies the extent to which deviations from a model could be expected to occur by chance. Okay, so you just do a confirmatory test. I think in chemistry, I think if you all have done a chemistry lab, you would have done this, the salt analysis. We find out what salt it is, and then we do a confirmatory test. Okay, so that will basically tell you whether it is actually that particular salt or not. So here also it is about the same. So the EDA and CFA, the exploratory data analysis and the confirmatory data analysis, should go hand in hand. Exploratory data analysis is like a detective work. Okay, it is a process of gathering evidence. You just go and collect data, and then you present it. It's like a court trial. You present it to the court. They find out which is true, which is not true. Okay, so normally what happens in a court trial is the law enforcement agency normally presents the evidence, what they have found out by the collection, by the data they have collected. So the judge basically goes through all that, and then each side, he looks at the data from each side and tries to come to a final conclusion saying that whether the evidence collected by the law enforcement agency points to a criminal offense or not. Okay, so sometimes it is there, sometimes it is not there. So yeah, it is something like that. So basically both should work hand in hand. One cannot work alone. Exploratory data analysis alone cannot solve the problem. The confirmatory data analysis is needed. Okay. The next is predictive data analytics. This uses many techniques like data mining, statistics, modeling, machine learning, and artificial analysis to analyze current data to make predictions about the future. For example, you have a large volume of data. Okay, so then this predictive analytics can be used to predict the future. For example, if you know when the traffic is going to be heavy, yeah, you can predict for the future. Okay, Sunday the traffic will be less, Saturday traffic will be high, but if Sunday is a festival day, yeah, maybe the traffic is going to be heavy. So all these things you can predict with the amount of data you have collected. Next comes the text analytics. This is process of collecting high quality information from text derived through devising patterns and trends through means such as statistical pattern learning. This is what some companies do. I think during the last election, there was a lot of issues with this type of analytics that was done by a company called company from London, which took all the data from Facebook. It did some analytics on what was being talked in Facebook. Okay, and then they derived and gave it to certain political parties, and which they made use of during their election campaign. Okay, so there were some issues on that, how whether data is safe or not. Yeah, this is the privacy issues I was talking about. We are worried about whether our data is going to be secure or not. So this is another type of analytics, because people write in using different words. So you need to find out what words, what model they all use, and then you need to find out what people are actually talking about, what people are interested about, and so on. So that may help a lot of other people as well, especially businesses. Okay, so we have seen about what is IoT, what is data analytics. Let's look into some of the applications where these things can be applied. The first one is healthcare. Healthcare is very important. You need to provide quality healthcare. We'll see how it is going to be there. Then comes the elderly people activity monitoring. Again, next is transportation. I have given enough examples on transportation now. Agriculture, traffic management as well. First, let's look into the healthcare. Okay, the inclusion of IoT gives decreased costs. For example, you don't have to go and meet the doctor every day. Certain things can be done through computers. For example, you are measuring the blood sugar of yourself. Maybe you are a diabetes patient and then you want to do the blood sugar measurement. Nowadays, you don't have to go to the hospital, and you have the machine which can measure it for you. And if these machines are connected to the hospital, then the hospital servers can give you a feedback saying that, hey, watch out, your blood sugar is showing some increase or decrease compared to 6 months earlier. Maybe it has increased slowly. We may not have noticed. We thought it is within normal, but it can give you some heads up saying that it is going up. Next is the improved outcomes of treatment. Because the doctor now has a lot of information about your blood sugar variation, he can give you a better treatment, and that can give you a better outcome. And then that leads to improved disease management, reduced errors, and enhanced patient experience. Okay, because now the patient, without visiting the doctor, maybe he visits only once in 6 months, he gets a better experience in how his disease is being managed. So that is about the healthcare, and this picture shows about these sensors. Okay, so you have a lot of these sports fitness bands and handheld devices and so on. All these can be connected to the doctor's office. So the doctor can basically or the hospital can basically analyze this data. And to analyze this data, you don't need a doctor in the first place. Some of these data are very well known. you can straight away give a diagnosis programming on the servers of the hospital, give you some suggestions on what needs to be done. Okay, so that's something on the healthcare. Next comes the elderly care. I think in India there is an issue. People live. India is a big country. Okay, people may be from the southern part, but he is working in the northern part. The parents are staying back at home in their own hometowns, or people are living overseas, like myself. My parents are back home in India. How do I monitor them as they get old? I can leave my job and come here to take care of them. Neither, sometimes some of the elderly people may want to move in with you. Yeah, then it is fine. But some of them, they find it difficult because they cannot leave their home. They feel like they are attached to the home. Their friends are there. Their circle, the friend circle is there. So they may not want to leave their hometown and come and reside with people overseas, or with even say from Tamil Nadu going to Delhi. Maybe they find that they do not know anyone. So why would they want to be there? So they don't want to go and live there. They will want to live back in their hometown. So how do you monitor them? Putting a CCTV is a solution. Yeah, but then it intrudes into their privacy. You're watching what they are doing. Instead, if they can have all these bands which tell you what is happening, and if all this data is moved into the cloud, and there is a service, okay, a particular company provides a service to collect all this data and gives you information to the son or daughter to who they are, who they have authorized. Maybe like, for example, there is a fall sensor. Okay, if somebody has fallen in the house, in the toilet or somewhere, and if the fall sensor can give a notification to you, you can straight away call the ambulance to go to the house door who is living to your parents to go and see what is happening there. Or maybe if their heartbeat is not regular, then you can ask them to go to the doctor, or you can ask the doctor to visit them as well. So these things are something you monitor them remotely. You are not watching them physically doing things. You basically say, for example, a person opens the fridge 10 times a day. Then suddenly for the last 2 days, it is opened only for once a day. So you know that something is not right. Maybe they are sick, they are not eating, or they are having issues with the fridge. Okay. So in any way, you can understand you can collect all this data and put it on the cloud, and then a particular company. Currently, there are no companies doing this. This is another business idea I'm just giving you all. You all can think about it. Currently, there is nobody doing this. In future, if some company comes with this, it will be helpful to a lot of people who can take this data and then get back to their parents. Okay, say for example, you can call back and ask what happened. Have you not been eating or whatever it is? You can just make a phone call and find out what is happening. All these things don't need a big, don't think the sensors are going to be very complex. Your fridge already has a switch which switches on the light and so on. So you can use the switch as a sensor to transmit data to. Only thing, the fridge needs to connect to the internet. So you need to put a device to collect the data. That's it. And this enables the elderly to be independent. Sometimes old people, as you all know, they do not want to be, they feel like if you are monitoring them very closely, they feel like they are not independent. They'll say, yeah, I'm good. Yeah, you need to leave them to be on their own as well. And the service, it can be connected to the emergency services as well. Okay, so this is some sort of connection we are talking about. We have a lot of sensors. We have heart sensor. You can have the diapers are there. If any senior people are wearing diapers, and if the diaper is wet too much, and if they have not changed it, maybe they are sick. Okay, you may have to call someone to go and check on them. Yeah, you can basically find out from a lot of these sensors which are already available. Okay. Next is the transportation. Okay, here we are talking about connected vehicles. Okay, so These days, connected vehicles are getting popular, especially after Tesla came out with a car that can be upgraded over the air through the internet and so on. And also, you have to know that all your cars, the modern cars, have got a lot of sensors. All these sensors are monitored, managed by a company. The car. So everything is there. Only thing, it has to be internet service. Currently, all this data is taken out by when you take the car for servicing. They have something called the OBD port, which is under your steering column. So they just plug a computer in, they download the data, they know what's wrong with your car. So basically, this data, if it can be transmitted to a service center, they can already tell you whether there is something wrong with your car or not, or the computer there can tell you, hey, your engine pump is not working properly. Maybe it may fail in another 1 month. So whenever you find time, you better drop in by the service station, and maybe it can give you some prescriptive analysis saying that you go to this workshop near your house, they are giving 10% discount on the same fuel pump. Okay, so that's about that. And then because of this connected vehicles, because of these vehicles getting connected, autonomous driving is made possible. People may think that, yeah, we just put sensor, the car will drive automatically. No, you fix cameras and sensors, and all these cameras and sensors are connected to a centralized server, which does all the analytics and tells the car back saying that, hey, that's a dog, that's a cat, that's a human being walking, that's a human being going on a cycle, motorcycle, there's a car in front of you. How does, because enough capacity, the computer is a small computer, very high. Yes, 4G is very fast as well, but 4G does not have the support that capacity. So being promoted, what do you call it, in a rushed manner, because
Am I audible to everyone? Hello.
Yes, you are.
Yeah. Actually, here we are facing a little bit network issue, and sorry for that. So everywhere it's a bad network due to a rainy condition. So I thought, have everyone audible to everyone? Yeah. Hello. Yeah, it's audible. It's audible. Actually, here we are facing a little bit network issue, and sorry for that. Yeah, everywhere we are facing that. So everywhere it's a bad network due to a rainy condition. Am I audible to everyone? Monica? Dr. Monica, are you there?
You are audible, ma'am.
Yeah, are you getting my voice a little bit late?
Yes, something, but it's okay. It's okay. I'm getting your voice properly.
What about the others?
Yes, ma'am. Yes.
Please
Yes.
unmute your.
Yes, we are here.
I have unmuted, ma'am. I
What
have
about?
unmuted.
Yeah, what about Mr. Anku? Mr. Azai Abdullah? Shall we? Please unmute yourself and give me your voice. Give me your presence. I hope everyone is audible with my voice. Kindly confirm your presence.
Yes, ma'am. It's audible.
What about others?
Yes, ma'am. It is audible. I think it's audible to all.
Okay, shall we start the session now? We'll go into the technical session.
Yes, ma'am. It's audible.
Okay. I request Mr. Raja to come forward to present his paper on a comparative study on intelligent combustion quality monitoring and control in power station boilers using an image processing algorithms. Mr. Raja? Next, I request Mr. Haran Kumar to come forward to present his paper on unmanned continuous health monitoring system based on IoT and intelligent app. Mr. Haran Kumar, you can start your presentation by sharing your screen. Mr. Haran Kumar?
Yes, ma'am.
You can start your presentation. Already I called you.
Oh, okay, ma'am. I will start now, ma'am. 1 minute, ma'am. I will share my screen, ma'am.
Yes.
Ma'am, is it visible, ma'am?
No.
No, ma'am.
No. Yeah, now it's visible.
Oh, okay, ma'am.
A pleasant good afternoon to one and all present here. This is Gayatri Shweta, and along with me here is Arun Kumar, Arita, Mirinalini, and Pavitra. We are currently pursuing our pre-final year in the stream of Electronics and Communication Engineering in Rajalakshmi Engineering College. Our paper is based on continuous IoT-based health monitoring system, which we titled as an Unmanned Continuous Health Monitoring System. The proposed concept of our paper is to monitor the health of the person continuously by the smart IoT-based wristwatch. This wristwatch continuously monitors the temperature, pulse rate, blood pressure, and sugar level of the person who wears it. And it also stores these parametric data in the cloud for the future analysis. If any abnormal changes occur in this parameter, then the notification is sent to the doctor and to the caretakers. The next few slides will be explained by Arun Kumar.
Existing system. In the existing system, the patient must go to the doctor in his hospital and get treated by the hospital and in the existing smartwatch there is many features like in our system, but it is not connected to the doctor. by by our system. By our system, the doctor and the guardian who is taking care of the patient can see, can check the patient's health condition, and moreover, by using this wristwatch, the patient can also check their body condition themselves. This is the novelty we made from the system. Over to Pavitra. And technical flow. Technical flow. In technical flow, the which process gives us the four parameters like pulse rate, blood pressure, temperature, and sugar. The pulse rate, blood pressure, temperature, and sugar, their value is displayed in the watch as well as in the application made by us. By this, the doctor as well as the patient guardian can check their health condition respectively. By this system, there won't be any in hand condition to check individually. By this, more amount of money can be reduced in the hospitality, and it will be easy for the patient. Over to Pavitra.
Pulse rate. The sensor used to measure pulse rate is EC0567, which is reflection type pulse sensor. This sensor emits infrared, red or green light. It measures the amount of light reflected using a photodiode or phototransistor. Also, since reflected light is measured, the range of suitable areas is not limited with transmission type pulse sensor. A working principle of pulse sensor. Pulse sensor has two sides in its construction. One side is the combination of LED and ambient light sensor, while the other side consists of the circuit. The circuit is responsible for the amplification and noise cancellation work, while LED on the front side of the sensor is placed over the top of the vein, either be your fingertip or ear tip. Implementation: VCC and ground pins both at 5V or 3.3V system, and connect the signal pin to the ADC pin. The result of pulse rate is shown in the wristwatch and as well as in the application. IoT based sugar test. The sensor used to measure sugar test is MESHD 015190, which is sugar level self-monitoring sensor. The design of the sensor integrates a disposable sweat analysis strip with a wearable smart band. Implementation: user first attaches a sweat strip to the desired area of the body and wears the smart band on the wrist. It uses Bluetooth protocol. Sweat glucose analysis using the device was determined to correspond closely with the blood glucose measured by the commercial glucometer, verifying its reliability. The result of the sugar test is displayed on the wristwatch and as well as in the application. Now over to Mrinalini.
Now I am going to explain about the temperature sensor. This sensor is used to detect the body temperature, and the sensor name is MAX 30205. And the sensor is placed in such a way that it touches with the skin. And the accuracy and the temperature ranges are measured in terms of centigrade and Fahrenheit. For example, the temperature range in Celsius is plus 37 degrees Celsius to plus 39 degrees Celsius, and its accuracy is plus or minus 0.1 degrees Celsius. And similarly, in Fahrenheit also, the temperature ranges from plus 98.6 degree Fahrenheit to 102.2 degree Fahrenheit, and its accuracy varies from plus 0.18 to minus 0.18 degree Fahrenheit. And similarly, other values are also plotted here. The next one is blood pressure. The sensor which is used for detecting the blood pressure is BMP180 sensor. And the blood pressure is measured in mmHg. Here, the systolic value and diastolic values are displayed both in the smartwatch and also in the application. And the blood pressure varies in accordance with the surrounding. Preferably, the blood pressure should be checked at rest condition. Over to Harita.
The camera that is used in the system is digital with CCD image sensor rather than using CMOS image sensor. Now let us see why we are using CCD image sensor. When the light falls on these image sensors, they get splitted into n number of pixels. Each square in the diagram on the right represent this pixel. CCD image sensor transports the charge across the chip and reads it at one corner of an array. An A to D converter then converts each pixel's value into digital value, whereas in CMOS uses several transistors at each pixels and move the charge using traditional wires. While doing so, CMOS can produce errors. Hence, CCD has high quality and low noise than CMOS. So, we used CCD image sense camera. And some of the specifications of the camera are, it has 1080 pixel. In short, we can say 2 MP. It is of size 2.8 millimeter. Why we need an embedded camera in system? In the cameras, why we need an embedded camera system in the IoT based wristwatch? To have a real-time face-to-face communication between physician or guardian and the patient when the patient's condition is normal or abnormal. Emotional condition of the patient by physician or guardian can be viewed through this watch. We can also take pictures to have some fun time with the camera. Now, let us look at the mobile application. It is a computer program designed to run on mobile devices such as phone, tablets, or watches. First, the watch should be connected to this app via Bluetooth. Once the app is opened in the mobile phone, there is a color indication to denote the abnormal and normal health condition of the patient. We basically have 3 color codes. They are green for normal, orange when there is a mild rise in any one or more levels, red when there is an extreme rise in these levels. There are 3 categories under which this app works. They are as a patient, as a guardian, as a doctor. This app is designed in such a way that the normal values are fed into the app. When we select as a patient, the 3 dot appears on the right. The 3 dot consists of view demonic. The options are as follows. The monitoring system, settings, app guardians, call doctor, send message, history, quit app. Let us now see each option in detail. In the monitoring system, we can see 4 icons. When we swipe up, we can see the 4th option. They are pulse rate, temp check, blood sugar check, and BP check. When we press the pulse rate icon, it shows the recently measured pulse rate. By pressing the temp check icon, we can see the recently measured body temperature. When blood sugar check icon is pressed, it shows the recently measured blood sugar level. And when we press the BP check, it shows the recently measured blood pressure rate. If any one or more of these levels goes high or low, the indication will happen. That is, a message will be sent to your guardian, to your watch, and to the doctor. In settings option, we can choose how many times and after how many hours we want to check these levels. The drop-down option next to each of the options in the settings screen makes us to select how many times per day or month or week we need to check these levels. App Guardian option will access the patient's contact list. From this, the patient can select whoever he or she wants to be his or her guardian. Call doctor is used to call doctor via phone and watch to have a direct communication with the face-to-face communication with the doctor. Send message is used to send message to doctor and the guardian. History is used to track the patient's health condition. It is represented in graph format. Quit app is used to come out of the app. Call doctor, send message, history, and quit app options performs the same operation in all 3 categories. When we select as a guardian option, the 3 dots icon can be we can see the following options: call doctor or patient, send message, monitor, history, quit app. Monitor screen of the guardian shows the recently measured values of the patient. Other options perform the same operation as that of the patient's category. When we select as a doctor category, we can see the following options: call patient or guardian, send message, monitor, history, and quit app. Monitor option performs the same operation as that of in the guardian's category. When we see the option that is call guardian or patient option that in the doctor's screen, it shows only the contact numbers of the patient and the guardian selected by the patients. Over to Gayatri.
Moving to the other features of our device, it has some basic features of smart wristwatch. It has a facility to see notification such as abnormal health condition, messages, calls, reminders, and mails. It has a memory card slot which can use it to store songs and pictures. It has a calling and video calling facility and also has an access to Wi-Fi and Bluetooth for the network connectivity. And moving to the conclusion, in the pandemic situations, using of this device will be very useful, and this device also reports a small variation in the parametric data, and it also brings the connectivity of the patient and the doctor continuous. By this, the person can consult a doctor from any part of the world. Moving to the reference, these are the papers and websites we are referred for our paper. And that's all about our paper. Thank you.
Thanks, Haran Kumar and team.
Thank you, ma'am.
Thanks for the wonderful presentation. Next, we welcome Mr. Razai Abdullah to come forward to present his paper.
Ma'am, can I stop my presentation, ma'am?
Yeah, sure. You can stop the screen sharing.
Okay, ma'am. Thank you, ma'am.
Thank you.
Ma'am, we shall leave.
Abdullah, sir.
Ma'am, one doubt, ma'am.
Please mute yourself after presentation, Haran Kumar.
No, ma'am, I have one doubt, ma'am. We shall leave the
You
meeting.
can chat. Please don't interfere in the conference. You can chat. Please give way to next participant. Mr. Abdullah, sir, you can come forward. Abdullah, sir, you can start your presentation. We are seeing your PowerPoint.
Overview of interference mitigations in enterprise-defined enterprise communication.
Sir, little bit louder. Your audio is low.
generation of cellular network, 5G, are expected to provide higher data rate, less end-to-end response time, and less device power consumption. In order to fulfill this requirement, a lot of new technologies are required. One of the main technologies recommended for improving.
Mr. Abdullah, sir,
Yes.
your audio is not clear. Please little bit louder, sir.
Little bit louder, yes. Next generation of cellular networks are expected to provide higher data rates, less end-to-end response time, and less device power consumption. In order to fulfill this requirement, a lot of new technologies are required. One of the main technologies recommended for improving spectrum usage in 5G cellular networks is device-to-device communication. This presentation provides an overview on some proposed techniques.
I think he's talking on mute.
Yep, yeah, now it's audible. Please go ahead, sir.
No, he's not talking. It's. I think he's talking on mute. Can somebody unmute him?
Yeah, just no, it's already unmute only.
Okay.
No, it's already unmute. His voice is low actually.
Okay. But still, I am unable to hear him.
Yeah, myself also facing the same problem. Okay, let me talk to. I think he is running away the slides.
Generation networks are envisioned to meet high end-to-end requirements, depending on three features: ubiquitous connectivity, extremely low latency, very high-speed data transfer. 5G is predicted to be an intelligent technology and potential can enable for the Internet of Things, the promising technology that tends to revolutionize and connect the entire world without limits.
Sir Abdullah, sir.
Yes, ma'am.
Sir, your voice is not audible. It's very low. Participants are not getting your voice clearly. Please make sure that mic is on and you unmute yourself. If possible, increase your audio volume. Am I audible to you?
Yes, you are audible, yes. Introduction. Do you hear me? Do you hear me like that? Sir, do you hear me like that?
Please make sure that your mic is near your.
Yes, I put it near my mouth. Do you hear me like that, sir? Hello? Do you hear me like that?
Sir, I'm not hearing your voice. Hello.
Yes. Do you hear me like that?
Your voice is slow, sir. Your voice is very low.
Very low.
Can't able to hear you.
Is it? Do you hear me now? Hello?
Sir, increase your system volume or increase your mic volume. Kindly check those things.
Yes, I increase it to the max. I increase the volume to the max.
At least mention me what's the issue you are facing in chat. What's the issue over there?
Yes, can I continue the presentation? Like that. Is it audible? The fifth generation networks are envisioned to meet high end-to-end requirements, depending on three features: ubiquitous connectivity, extremely low latency, and very high-speed data transfer. 5G predicted to be an intelligent technology and potential enabler for future Internet of Things. The promising technology that tends to revolutionize and connect the entire world without limits. Internet of Things networks in 5G. According to International Telecom Union standards, Internet of Things is global infrastructure for the information society that enables advanced service by interconnecting physical and virtual things based on existing and evolving interoperable information and communication technology. Internet of Things with 5G networks are expected to provide high data rate, high service availability, low latency, and high capacity density, and high spectrum efficiency, and high energy efficiency. Internet of Things networks can be used for a wide range of applications like domestic application, social application, environmental application, technological application, and emergency application. Device-to-device communication in Internet of Things. Device-to-device communication is a new paradigm in cellular networks which allows the user equipment in close proximity to communicate using direct links. Device-to-device communication can be classified into two types. Device-to-device communication using licensed spectrum known as in-band, and device-to-device using unlicensed spectrum known as out-band. In-band device-to-device communication depends on central controlling entity, which is the node or the base station, which gives support for resource allocation, interference management, security and privacy control. In-band device-to-device communication divided into overlay mode, which is efficient in the control of intra-cell interference, but less efficient for the reuse of global cellular resources, and underlay mode, which improves the performance of cellular networks in terms of spectral efficiency, cellular capacity, and energy efficiency, but it is not efficient in the control of intra-cell interference. Out-band device-to-device communication reduces and eliminates device-to-cellular interference, but it brings more challenges like peer-to-peer discovery, encryption, decryption, and security issues due to unavailability of central control entity. Out-band device-to-device communication is further divided into controlled mode. Radio interface between device-to-device links controlled by the base station or the node. In autonomous mode, the base station controls the cellular communication only, leaving the control of device-to-device communication to device-to-device user. In the shown figure, underlay uplink-downlink reuse model. In the left, the uplink reuse scenario. In the left, the uplink reuse scenario. The device-to-device pair reuse the resource of cellular uplink, producing the interference on the node B, and the other device-to-device pairs using the same channel. On the right, the downlink scenario is presented, where the device-to-device pair use the resource of cellular downlink, producing interference on cellular user and the other device-to-device pairs using the same channel. In uplink reuse scenario, the instantaneous signal to interference plus noise ratio of the cellular user and device-to-device can be expressed as the following equation. In downlink reuse scenario, also the instantaneous signal to interference plus noise ratio of cellular user and device-to-device can be expressed by the following equation. Interference mitigation chance in underlay device-to-device mode. Interference mitigation using pricing chance. The price have the economic interpretation that are actually system parameters designed in a resource allocation scheme. These parameters depends on the interference caused on the associated cellular user or base station. The base station manages set of prices and each device to device pair adjusts its transmit power in order to maximize its own value of function. That is defined as the difference between its transmission rate and the payment added due to the caused interference of cellular user or the base station. If the end cellular user fails to guarantee the minimum data rate requirement, then the base station increases the reduced price for the end sub-channel to force device-to-device transmitted to reduce its transmit power. Interference mitigation using priority channels. The idea is to manage the reuse of cellular resources by device-to-device users, taking in consideration the priority of cellular user to fulfill its service guarantee. If the achievable limit of the end cellular user is lower than the minimum cellular rate, the power of the device-to-device transmitter, which yields the heaviest interference on the end channel, is decreased by the minimization of channel gain between device-to-device transmitter and cellular user, or by the assignment of different weights to cellular application and device-to-device application, which gives different priority to each of them. Another interference mitigation use is interference mitigation using graph theory. The channel allocation problem is transformed into coloring problem where the color corresponds to channel. Vertices represent cellular and device-to-device users, and edges represent the interference between the two versions. Coloring vertices is equivalent to allocating channel. The edge connecting two vertices indicates the independent and the cumulative interference between them. Vertices are connected by an edge if the wanted signal to interference plus noise ratio is below the interference threshold level. So it prevents signal user and device-to-device user from using the same channel simultaneously. Another interference mitigation scheme with using cell sectorization and fair frequency reuse technique. Here, the cells are divided into center zone and edge zone, and different subbands are assigned to each zone. The available uplink spectrum S is partitioned into two bands, for example, S0 and S1. S0, the frequency band assigned to user located in center zone, and S1 is the frequency band assigned to user located in the edge zone. To mitigate the intra-cell interference, device-to-device users in the center cell region can use the resource of cellular user located in the edge zone, and device-to-device located in the edge zone can use the resource of cellular user located in the center zone. The above interference mitigation schemes depend on the control of transmitted power of device-to-device or cellular user or node or base station, which means that the control of the transmit power considered the main key to solve the interference issues in underlay device-to-device communication. However, in overcrowded and dense cells, the management of the transmit power and the interference becomes more complex due to the proximity of node and user ends. Hence, some techniques have efficient and practical solutions than others, like cell sectorization technique, which divides cell into zones or sectors, and each device-to-device they reuse the resource of cellular user of other zones. Conclusion: device-to-device communication is considered promising technology in Internet of Things and 5G network. However, the challenges facing this technology, like interference between cellular users and device-to-device users in underlay mode, impose real issues, needing efficient solutions before its implementation. Thank you for your
Thank you, Abdullah sir.
Thank you, sir.
Next, I would like to call Dr. Monika Saxena to come forward to present her paper on security approach for anomaly detection in multi-sensor environment, charge, and health status.
Is my screen is visible, ma'am?
Yeah.
So can I start now? Am I audible and visible?
Yeah, it's clear of audio and video. You can go ahead, Miss Monika Saxena. You can go ahead with your presentation.
Okay. Thank you, ma'am.
Yeah.
Okay, so good afternoon, everyone. I'm Monika Saxena, and I'm working as assistant professor in Vanasli Vidyapith, Jaipur. And I'm here to present my research paper on IoT dynamic log file analysis, and that is a security approach for anomaly detection in a multi-sensor environment. So the contents of the presentation are abstract, introduction, research motivation, problem statement, research methodology, implementation detail, conclusion, and the references. So first I come to the abstract. So as we know that in the multi-sensory environment, the valuable information like the user interaction with the smart IoT devices and the web server are stored in a generally a log file. Like simply if I'm using any of the IoT application and the user are accessing that particular IoT devices, then we can fetch that particular user by that login information. Okay, so here the web access log plays the important role in the terms of the security and the privacy of the users. So to detect the anomaly, or we can say for the intrusion detection, we can use to analytics the loggings of the device system. So the fetching of the needed information and the mining of the logs and the modeling of tasks and prevention from the unauthorized access is the main aim of this research. For that, we have developed a framework and the methodology that is proposed for the same, that is in a research paper. So the main aim of this framework is to model and examine the HTTP request. As we know that in the IoT, we can use the MQTT as well as COAP in the IoT application layer, but we examine generally the HTTP request for the IoT system. So we are using the HTTP request log analysis here, and a methodology that is used to analysis the IoT users. That obviously HTTP supports the IP and the TCP. So we are just added on the HTTP request, which is IP addressing as plus the TCP IP packet or the segment information. So the IoT log file and the proposed framework that enhance the security and the privacy of the users by detection of the anomaly user requests. If we come about the introduction, then as we know all of basic of the IoT, that IoT are divided in a 3 type of world. It can be a complete physical, it can be in a digital world, and it completely a virtual world. So we the user can any of the user can access there any of the thing, same as it is available at the any time, any place, and we can access it and on any network, and we can perform with the any services. So the main concern is there, that is the IoT security. So many of the security are applied on the application layer at the physical level also. But if we talk about the intrusion detection, then the intrusion detection is basically a process of monitoring the events that is occurring in a computer system or a network, that is analyzing them for the possible incidents. So IDS is a software that automates the intrusion detection processes. So basically we are talking about the network based IDS here, that is NIDS. It monitors the network traffic for the particular network segments or devices and analyze the network and application protocol activity to identify the suspicious activities. So here we are using the log analysis system This is the security log analysis system that is also known as a log-based intrusion detection system. And the log analysis for the intrusion detection is the process or a technique that is used to detect attacks on a specific environment using the logs as the primary source of the information. So what is the basic IoT logging? So we can say the logging is a method of recording events and the functions on the computer. So if we talk about the IoT, then we generally use the Raspberry Pi and the Arduino on, or we can say on the edge devices. So the log messages can be stored in a file like the /var/log directory. So we can fetch that data from there and we can analyze them. So this is the example of a IoT logging log information. So the first example is based on the HTTP protocol. So we can see here that the frame number, frame time, frame length source, frame length, frame destination, IP source, IP destination, IP ID, protocol ID, length, TCP source, and TCP destination port, and all information are available here in the logging information. So this is the example log of the above format. So if we simply send data in a HTTP over the HTTP, then we'll get the login information in like this format. This is the second format. This is generally used in a IoT, that is device name / track ID, module name, and content keyword and the time range. And this is the example log for the same. So we are basically having the two types of log information is here, and according to that we can analyze that how many users are accessing that particular application. Here the one important thing that is used in a logging system, that is syslog. Syslog file is used to maintain the complete log data. So generally it is used to collect the log data, pre-process the log data, filter the log data, and they can store the log data also. So we can fetch the log data over from there. So basically we are having the two types of logs in a multi-sensor environment that are divided into two categories. So first category is the time series log, and the second one is the non-time series log. So the time series log are generally dependent on the IoT applications like a temperature. Like if we need to calculate the temperature in a particular time slots, like I'm just taking the data from the temperature sensor in 1 hour. So this is a time series logs. Same as the some of the IoT application supports the non-time series logs. Like if you talk about the home automation, where user comes and according to that light gets on and off. So this is just a non-time series logs. So we are discussing about the both here. So the if we talk about the IoT application, then they can generate the time series log as well as the non-time series logs. What is the problem statement there for this particular paper? So we can see here that we need to analyze both type of logs here, that mean time series logs and the non-time series logs. We need to filter a complex format, and we need to define that in a structured format. This is generally called a data cleaning, and we need to detect the anomaly users and the intruders from them, and we can provide a secure multisensory environment there. So the research methodology that I used to perform that particular task is we are collected the unstructured heterogeneous data from the different web sources. That is, for example, generally we are collected the data from the edge devices. We know that edge devices is containing the data of multiple sensors, or if in generally the gateways also having the multiple log files, so we can connect our data from the gateways and from the edge devices. The unstructured data of the log file is passed into the structured data, and the data is pre-processed, mainly the removal of the unused data. Basically, this is the method of the simple data cleaning, or we can say the machine learning, we can say here. And finally, whatever data that we get, and that is implemented in a Java programming language and in the MATLAB. So from that, we are fetching the multiple IP addresses of the intruders. So these are the some of the research bases. It comes in the following points. Like firstly, we need to understand the data. So in the simple data understanding, we are fetching the relations, patterns, and the principles in between the data. Then the smart data preparation means cleaning and the integration, selection, and the sampling of the data. At last, we modeled the particular data in a form of conceptual, classical data reduction and the physical modeling. And lastly, we deployed data and compared that particular data to secure our IoT environment. So this is the methodology that we performed to perform that particular task. That is, we collected the data from the web server. We applied the parsing tools. Then structured data comes and pre-processing applied. Then clean data, and finally we are classified the output in a 3 forms. That is, the output is a normal form, suspect, and the attacker. Okay, so proposed architecture for the same is like data is collected in a form of static and the dynamic both. And after that, the proposed algorithm is there. That the proposed algorithm is basically based on the multi-level hashing scheme. So that multi-level hashing scheme is used to find the particular pattern, and according to that particular pattern, we can find out that how many users and how many persons comes to perform that particular application. So we can fetch the intruders or the other IP addresses from there. Then there is a data fusion method is also used. So we are collected the multiple data and we are applied that into the distributed data fusion method in the same proposed algorithm by the multi-level hashing method. And finally, we will get the final model, means final aggregated, or we can say the final log data. So this is the proposed approach. Here we find the precise pattern, and we can merge that particular pattern and we can create the pattern hierarchy tree. And finally, we'll select the particular pattern, and according to that, we can find out the intruder. So this is the method that we applied. So this is the raw data that is collected from the multiple sensors. Then this is the clean data form. Here the data is available in a simple integer format, so we can analytic that particular data easily. Okay, in the implementation detail, all of the data that is collected from the gateways and the different sensors are generally available in the .log format. So if we are collected already in the .log format, then it's okay. Then we can, if they are not in a log format, then we must convert that particular into the log format. So the web server log and the firewall log of both firewall server and the desktop system are converted into finally a structured format. And the structure log is inserted into the database where the already learned database are available. So after that, we can remove the noise there, and we can find the intersection of the log files is also there. So generally the need of the intersection is that we can compare the previous logging with the current login, and we can find out the intersection of that log file. And finally, the result of the calculated and the whatever log file is calculated of IP address of the intruder, that comes into the result.txt file. So from that, we can identify the IP address of the anomaly users, and we can block that particular user to from our system. So this is the implementation available. This is basically implemented in a Java programming language. Here we can transfer the log file and convert to the database. And this is the example where the project runs, and it gives the record inserted if the all record are inserted. And finally, it gives the intersect output in a form of IP addresses. So they all are the sum of the IP addresses that are continuously used in a particular IoT application. So the conclusion of this particular research work is this: that by the log file, we can by the log file troubleshooting, security can be done. We can secure our network through IDS security. And by the analysis of the different log files, the researcher can identify the IP address of the intruders, and we can find out the timestamp value and the other details also. Okay, and that IoT data that is collected from the different log files are through that proposed method, and we are just analyzing that particular method. And in this, we can use the data fusion as well. And if we are collecting the data from the large IoT application, like if we talk about the smart city, then we can use the deep learning and the distributed data fusion method also. Okay. So these all are the references of my research work. So thank you.
Thank you. Thank you, Dr. Monika. Thank you so much. Then we'll switch over to next presentation. Let me call Ms. Rakshita Ravi to come forward to present his paper on charge estimation of a lithium ion battery in an electric vehicle using IoT modeling techniques.
Can you see my screen, madam? Is the screen shared?
I think you get the last screen. Yeah, I'm seeing your screen.
Is it visible?
Yeah, your audio and video is perfect. You can go ahead.
Yeah, thank you. Good afternoon. This is Rakshita. I'll be presenting on charge and health status of a lithium ion battery in an electric vehicle using IoT modeling techniques. So this is all about the flow of presentation, and basically before starting I would like to give a small abstract. In present scenario, internal combustion engine is overcome by electric vehicle due to many advantages like less carbon dioxide reduction, cost, weight, and there's no dependency on fuel stations, many more. Extensive research is going on electric vehicles, and one such concept is battery management system. A battery management system is a very very important concept because a battery is involved in view of an electric vehicle. So for an electric vehicle to be effective, battery management system should be well designed, and since battery is involved, and that is lithium ion battery is involved, the management system plays a very very important role. The main concept here is the IoT monitoring. So another important concept is the state of charge and state of health. Before the user starts his electric vehicle for a travel, he has to know what amount of charge is there and what is the health status of the battery. So this basically is controlled with the help of IoT using an Arduino technique, and it is very very important for the user to know the state of charge and state of health. When it is known properly, he can plan his travel by charging the battery in advance. There are many algorithms to calculate the state of charge and state of health, and one of them which I have used is Coulomb counting. Presently, Coulomb counting algorithm is used because it is suitable for both linear as well as non-linear system, and the methodology is also very very simple. There's no complex procedure involved. And IoT technique using Arduino platform is used here to monitor the electric vehicle, and if IoT is used, it can be easily streamlined. There are many techniques in IoT as well, and one of them which I have used is Arduino technique using IoT, and each of them have their own limitations as well as advantages. In places where mainly human intervention is not possible, IoT smart monitoring, that is IoT technique or IoT architecture, plays a very very important role. So as I told, this is the overview. Electric vehicle, basically the battery management system plays a very very important role, and there are two concepts, electrical and mechanical. In electrical, the charge status and the health status should be known to the user, and it is very very important, and that is monitored using smart monitoring technique called IoT Arduino architecture. And the algorithm which is used to calculate the charge and health status is Coulomb counting, which I have used. So basically EV plays a very very important role, and it is more advantageous when compared to internal combustion engine. Like, it has no tailpipe emissions, the maintenance is very less, and as I told, there's no dependency is not required. Charging can be done at home itself. There's no air pollution, it doesn't make much noise, hence it offers a very very smooth trip. And what is the need of electric vehicle? Less carbon dioxide emission, there's no fuel cost, there's maintenance cost is also very very less. And recently there was a survey conducted by BC Hydro. 55% of respondents identified that saving money on fuel and maintenance as their biggest motivation for buying an electric vehicle. So this is all about, there are different types of electric vehicle, and I'm basically concentrating on battery electric vehicle. And since battery is involved, there are many types of batteries, and I'm concentrating only on lithium ion because nowadays it is extensively used, and research is also extensively going on because it has its own advantages, like it is inexpensive, it is very very efficient, and maintenance wise the performance of that battery, it will last around 8 to 10 years, and less weight. When it comes to EV, weight plays a major role, and compared to other types of batteries, lithium ion battery plays a very very important role, and durability wise also it is more durable. And hence since research is extensively going on, and the main aim of EV is to reduce the carbon dioxide emission, because nowadays in traffic it plays a very very important role. The emission has to be less, keeping the health in view. And so when it comes to EV, the charge status and health status has to be known to the user. So with the help of IoT based Coulomb counting algorithm, easily the status can be known, and monitoring, if it is done using IoT, the streamline is easily done. And one more advantage with IoT Arduino technique, the identification of the nearby charging network station can also be given to the user. So there are, as I told, there are many algorithms, and I have basically concentrated only on Coulomb counting algorithm, because in order to calculate the charge and the health status, the parameters which I have considered is current and voltage. uh, th- the advantages is it is suitable to both linear as well as non-linear system when it comes to electrical point of view. And implementation wise it is very very easy, and error propagation is very less. And here the battery can be designed up to 1 kV, that is 1000 volts, and charging time required is also very very less, that is 30 minutes. And the type of charging used is DC charging type. And as I told, the error propagation is very very less, it can be reduced from 5% to 1%. And as I told, IoT is the monitoring technique or the smart charging technique. There are many techniques in IoT, but I am concentrating only on Arduino method. I would like to give a brief view on the previous IoT techniques used. IoT blockchain method. Here, what happens is the real-time confirmation is not possible, whether it is connected or not. If there's any error, from which type of, from which link the error is there, it is not possible. It is extremely difficult to identify, and data retrieval is also very, very difficult. And one more method, that is node-RED method. Here, what happens is, here the real-time confirmation is possible, the smart charging can be achieved, but the information cannot be given, the information can be given to the user, but it cannot be stored in the cloud. So if the data has to be needed to the user, he cannot retrieve that data, and it is very very difficult. But whereas in IoT Arduino technique, what happens, here Ethernet and internet, using Ethernet and internet, that is GPS facility, easily it can be known, the real time confirmation is possible, and the information can also be given to the user, and data retrieval is also very very easy. That means the charge status and the health status can be done. This is a small experimentation view which I have done. I have used IoT Arduino technique, a PCB board and a small breadboard, and by using the Ethernet connection, we have tried to note down the charge status and the health status and integrate that with the user. So this both experimental and simulation wise I have done. This is the simulation which is done in the MATLAB. This is the Simulink model to find out the state of charge. and these are the results which I have obtained. And here experimentally, here as I told, the user can obtain where are the charging stations and where are the petrol bunk, or the necessity, the immediate usage which is required, the user can obtain with the help of internet of thing. And there is one application called optimal electric vehicle charging application. Here what happens, by using this app, everything is integrated using EV. So here the battery capacity, the range, the available battery in percentage, everything can be given to the user, and this is the detail view. So this is so finally, if I want to conclude, the electric vehicles, since extensive research is going on and it will take on the future of automobile, the start status and the health status plays a very very important role, and that can be calculated using Coulomb counting algorithm. And when it comes to the smart monitoring technique, IoT architecture using Arduino can be easily done. So these are my references, and when it comes to acknowledgement, I would like to thank the team of IFERP for giving me an opportunity to present my paper at the conference IoT and Intelligent Apps. Thank you so much.
Thank you, Rakshita.
Thank you, ma'am.
Okay, now we will move on to next presentation. I will call upon Mr. Ankush Sharabat to come forward to present his paper on secure authentication of IoT devices in smart cities. Mr. Ankush Sharabat. Okay. Okay, next I would like to call upon Ms. Divya N. Sahatya to come forward to present her paper on effectiveness and of an automatic speech to sign language software for translation in improving knowledge regarding toothbrushing technique among speech and hearing impaired children.
Okay.
Others, please mute yourself.
Good afternoon, one and all. My team and me are here to present a project on the topic automatic speech to sign language software
Is
to
Divya,
improve knowledge regarding brushing
audio
technique
is
among
a
speech
little
and
bit
hearing
annoying.
impaired children. So we have done this
Divya?
project with a tie-up between the engineering and the data school of JSS Mysore, India.
Ms. Divya, your audio is a little bit
There are about
annoying. Background voice.
Okay.
Others, please mute yourself.
Good afternoon, one and all. My team and me are here to present a project on the topic automatic speech to sign language software.
Divya, do you have any issues over there?
Hello.
Divya, is everyone is clear over there? Do you face any issues in audio?
Can you hear me?
Yeah, now your audio and video is perfect.
Okay, thank you. So we are here to present a paper on the topic effectiveness of automatic speech to sign language software to improve the knowledge regarding brushing technique among speech and hearing impaired children. So we have done this project with the tie-up between the engineering and the dental school of JSS Mysore, India. To improve knowledge regarding brushing technique
Ms. Divya, what happened?
Hello, yeah, we're just representing it. There was an audio problem.
Okay, please go ahead.
Yeah. Oh, Aya, come on.
Divya and team.
Hello, yeah. Hello.
Am I audible? Divya and team, am I audible to you?
Yeah, yeah, yeah.
Please go ahead with presentation. Divya?
Yeah, yeah, we are presenting.
Among speech and hearing impaired. There are about
So to
6 to
start
15
on with,
million people
so
in India
hearing
who are
impairment is a
showing hearing
problem which is
impairment.
observed
Children
over
with such a
63 million
condition
people
are at a
across
higher
India.
risk
So
for
children
language
with such a
deficits
condition
and reduced
are at a high
cognitive
risk
skills
for
due to
language deficit
communication
and
barrier.
reduced cognitive
One
skills due to
such risk is the
communication
oral
barrier.
health
So
hygiene.
in
It is
oral
very
health
important
perspective, there ought
that
to
they
be an
have a
under
good
higher risk
hygiene
as the
in oral
magnitude
health
and the severity
perspective.
of
There
oral
ought to be
health
at a
problems
higher
in
risk,
these
and
children
the
are more than
magnitude
their
and
any
the
other health
severity of
counterparts.
oral health problems
Therefore,
in these
there is
children.
a need of oral hygiene
Therefore, there's a
education for
need
these
of an
people.
oral
So
hygiene
it plays a
education
very
for such
important role
children.
in
A
imparting
mode of
education
communication
to
plays an
improve their quality of
important role in
understanding. So
imparting
this will need a professional
education to
modification
such
of the
children.
ways
So,
the
therefore, we need a
communicating
professional
of the education
modification
in
of
these
the way
children.
of
So one
communication
such
in
example is
educating
to
them.
make use of written
Oral
instructions,
hygiene
or we can
education
make use of
can be
video modeling
communicated by
or
using
any
written
visual media which
instructions
is
or
understandable
video
by
or
such children, so
visual
that they
media
can
modeling are
understand
some of
and they
the
can learn
examples
it
can
very
bridge this
easily.
communication
So we
barrier.
came up with an
So we
idea
came
to
up with an
implement an
automatic
automatic
speech
speech
to
to sign
sign
language
language
software,
software
which
which
can be
can be
used to
used to
improve the
improve the
brushing
brushing
technique
technique
among children
among
with
these
hearing
children.
impairment.
So this tool can be used by the instructor or by the dentist chair side, and it will help to translate the dentist or the doctor's instruction to the respective regional sign language which is understandable by the patient or the child. So this is going to be really helpful for them, because it is very difficult to have a translator all the time with you, or maybe the parent or the individual will take a period of time to understand and to learn the sign language. So this software is going to be helpful for any two individuals who need to communicate with another individual having such impairment. Through this automatic speech recognition system, a teeth brushing technique based on sequence learning principle is used to educate the children. So we made a list of 82 Kannada words, and this can be extended to any language and to any limit based on the use and the purpose. Coming to the methodology, first a standard microphone is used to record the spoken word in a closed noise-free room. So once that is done, it is sampled at the rate of 8000 Hz, and the file is saved in the form of a WAV file. So this file is then filtered to remove any kind of distortion or noise that can be present. So once that is done, the filter signal is then passed to the feature extraction block. A machine cannot understand the real-time data, so we make use of feature extraction method. So feature extraction method extracts certain important features or the points or the details of the input signal, so that we can easily recognize it and display the corresponding output. So there are two methods which are commonly used for the speech signal for recognition system. So one of them is the LPC, that is a linear predictive coding, and the other one is MFCC. So we have made use of the LPC method, and once these coefficients are available, we train the neural network. So we have recorded a total of 15 speakers who have spoken each word 5 times. So this is an example.
Ujjiri.
As you can see, this sign output is being displayed.
Is everyone can able to see the presentation, PowerPoint?
No, ma'am.
Is it visible?
No, we didn't get your presentation.
You from the beginning you are not able to.
No.
Shall I start it from the beginning?
Okay, you please wait for some time. Kindly check the network you are having, Ms. Divya and team.
Okay. Okay.
I will call you for next presentation. Okay.
Okay. Okay.
Okay. Next, I will like to call upon Ms. Dr. Smita Shekhar and team to come forward to present their paper on detection and warning system using IoT system based on QRS factor.
Mute it. It's not stopped.
Mute yourself.
Hello, I am.
Mute yourself. Mr. Krupa Shagar, you can come forward to present your paper.
My screen is visible, ma'am.
Mr. Krupa Shagar, you can come forward to present your paper.
Ma'am, audible?
Yeah, you can go ahead. You have to share your screen.
Ma'am, my screen is visible or not?
Yeah, your profile photo is displaying. Start screen sharing.
I'm sharing, ma'am.
Yeah.
PPT is shown or what, ma'am? PPT is visible or what, ma'am?
No, we are not seeing your PPT. Real-time heart attack detection and warning system. Is
Yes,
this your paper?
Yeah, ma'am.
Okay, you can go ahead.
PPT is visible now, ma'am?
Yes, you can go ahead.
Okay. So myself, Krupa Sagar. I'm MTech student, Department of Computer Science and Engineering. So Dr. A. American Institute of Technology, Bangalore. Under the guidance of Dr. Smita Shekhar B, Associate Professor, and under the guidance of Dr. Harish G, Associate Professor, Department of Computer Science and Engineering, Dr. American Institute of Technology, Bangalore. And today I'm here to present my topic. So based on IoT and Intelligent Apps 2020. It's a topic on real-time heart attack detection and warning system using the IoT system based on the QRS factor. And the agenda of this paper is the mainly abstract. Why I'm bringing this idea to the real-time like a prototype. So in here explaining the abstract and introduction, what we did in the paper and objective and existing system, proposed system, requirement, implementation, result, conclusion, reference. Okay. So I'm going to explain about the abstract. Before going to the abstract, we are familiar with the heart attack. This is a disease. So why? So most of the time, patients go for several tests, which can overburden them with the extra physical activities, time, and additional financial charges.
Yeah, the first examination proposed the basic purpose for coronary illness can be unfortunate food, tobacco, exorbitant sugar, and overweight and over physical extraction. So healthcare is considered an important determinant to be uphold the general physical and mental health and the well-being of the people. And so here and uh, conventionally, the term health care is considered an important determinant to uphold the general physical mental health. To be concerned with the increase of heart disease and the heart attack, to be primary cause of the death in the world, is mainly due to the negligence of health monitor, complaining lack of due to massive workload and pressure. So medical accurate and extra prediction of the heart problem is ECG data. So it's approved. So here so you utilize the heart rate pulse. So it means pulse sensors module to interface to serial communicate to the Raspberry Pi board. And here the another features included in the project is the facial image recording by the camera in the ambient lens. And GPS module is used for location information. The prototype offers heart condition to monitor the across time and place over the internet and smartphone. So patient location for timely help with their concerned cardiologist. Okay, move on to the next slide. So it's the introduction. So based on the IoT, this e-health is helpful in developing IoT ideas. The heart is pumping the blood in the cardiovascular system, consisting the veins, arteries by which blood reaches in the all part of the body. This is common. So, but inappropriate diet or hypertension may cause to heart, which may lead to heart failure. So nowadays, because of COVID pandemic, so most of the employees doing like work from home. So there's a hypertension and inappropriate diet. It will cause to heart failure. So it is the main. So another cause is some most of the people at habit with smoking, drinking. So this is another case. So increasing the hypertension and heart dieting schedule people and number of heart attacks can also increasing this requires the automation of the health checkup. As past examination proposed the basic purpose for prediction. So we're going to predict. Okay. This system design which very helpful to patient and also produce if there are any changes in the condition of the health. Not only patient, their parents and also hospital management and also the regarding the doctor. Okay. So main objective of this paper is main purpose of this model is to build architecture is help to find whether person is met with a heart attack based on the user daily data. So we are going to predict the system when given input data from the pulse sensor. This is a sample of fingertip. Okay, so must be able to tell if the person condition minor or major. So based on the clinical data, system will able to differentiate in the stages of heart attack without any confusion because we are training with our data set with a 70:30. So we are going to 92% prediction. So heart attack is the primary cause of the death. So already I discussed. And increasing of the heart disease mainly due to the negligence of their health. Because so nowadays the massive workload, we are not going to the checkup every day. So we sometimes we took some tablets. So this causes to heart disease sometimes. So nowadays in the existing system in the marketing, there are many wristbands are available. So in the example, chest strap we are looking in the hospital. This is the main advantage is we can travel we can carry this chest strap because they are connected to the some electric wires. So this is the main advantage. And so main is polar OH1. This is now top one wristband. It feature is an optical sensor that is much easier to use than traditional chest strap. This is a primary benefit and major focus is this is a pair with a smartphone and device to review the heart rate data. And also, this heart rate monitor is also rechargeable and with a battery that provides 12 hours of use for charge. So here we are looking to the Polar OH1. They only introduced as for marketing purpose. Here there is no condition to contact with the doctors and there is not tracking. So I'm actually cancelling this existing system. Sorry. So next one is Garmin Forerunner 945. It is also a wristband and actually it is made for the athletes. And it's also including the music features and the impressive suit for performance monitoring applications and perfect to fitness and training models. And it is also it can provide you with a smart tip to keep your heart rate within the safety limit or show your progress over time. So either of these features will be available value to the person who want to improve their fitness as much possible. So when we actually looking for the what Redmi band, and it's like a Redmi band. So another one is Garmin Vivo Active 4. This is a smartwatch that features is an amazing heart rate monitor powered by the battery that can last for up to 8 days without recharging so long as don't use the including applications. So here also, but in this Garmin Vivo Active 4, this, another feature is including GPS mode. Sometimes you can lost the connection. You can from the territory, we can locate the same location. So same thing, but in that there is no special feature not included. So another is last one is in vision system. Fitbit Inspire what Inspire HR. So this is also wristband, and it is actually it contains a fitness tracker, and the other advantages include water resistance. So everywhere we are looking for the water resistance Bluetooth and fit tracker. But in this, it's a operable fitness tracker include many of these stuff you would accept from the device of the type, including calories burn tracker and activity tracker to helpful to nail down the perfect exercise routine. So ensure that you are active as a needed throughout the day. So looking for these exercise system, we are concentrating only on the what advertisement and music tracker Bluetooth. So we want actually the patient can monitor with and handle by the doctor, and so every if a patient met with a or a heart attack, so suddenly hospital management can track. So these conditions not so involved in this wristband. So over these come disadvantages. We are going to propose the this in the systems in the paper we are going to discuss here. So we implement the Raspberry Pi 3. So it's a so well-known familiar element. So it is IoT based heart rate prediction for element, and monitoring the system using Raspberry Pi 3. We utilize heart rate, so means pulse sensor module to interface to the MCP, and this MCP serially communicate to the Raspberry Pi board. It will fetch the pulse sensor MCP input and send to the cloud. Okay. So how actually input from the pulse sensor module we get? So using pulse sensor ECG signal will be collected and fed to the Raspberry Pi, and it will be processed using the signal processing method. Such that so number of the heartbeat can be calculated from sample ECG signal. Then based on appropriate threshold method, heart attack will be detected. So another case, if number of heartbeat is equal or greater than threshold value, then person will be considered normal and abnormal. Threshold value is selected after analyzing the number of heartbeat of a normal or a abnormal ECG signal based on QRS value of each heartbeat. So here you are concentrating on the QRS value from the signal. So next one is DWT based QRS detection. So discrete wavelet transformation. This is based on QRS detection. So here in the DWT based QRS detection, the number of the heartbeat selected before threshold value, and each heartbeat QRS value gives the abnormal ECG signal. So each ECG waveform graph will be represent the heart function. So name itself PQRST data point represented by the series of electrical pulses. Each point of peak gives an indices of any abnormality indices analyzed by the ECG waveform that occurs in the PQRST waveform. This is the main prediction of the QRS detection. So another feature we are going to detect from the patient. Sometimes it's a general thinking. When a patient met with a heart attack, sometimes the most of the people, aged people, are going to the unconscious. So we can't. That time the doctor cannot see the patient condition. Okay, but heartbeat is detected using the pulse sensor, so that we introduce the face skin color detection. So feature. So in this, detected skin region would contain the faces. Some of them will belong to other skin area, such as the neck, hands, etc. While others will correspond to object with a similar color to the skin. Thus, the method to detect where faces are in the segmented image must be developed. We are going to only capture the patient face, the patient is alive or what. So if a patient condition is detected, we are predicted. So the communication is going on, or else something is happened, okay, based on this condition. In that, after the face detection process is completed, The system creates the output binary image where every pixel is labeled as a foreground, that is face pixel, and or a background, that is non-face pixel. Therefore, the face detection problem is a segmentation problem in which the main goal is to find image region containing the face machine learning algorithm. Okay. So in that, so along with, so you're going to predict. So already told that I'm going to predict the heart attack is a minor or major. So using the random forest classification. So present day, one of the major application area of machine learning algorithm is medical diagnosis of a disease and treatment. Machine learning algorithm also used to find correlation and association between the different diseases. Nowadays, many people are dying because of sudden heart attack. We are discussing the prediction and diagnosis of heart disease become a challenging factor faced by doctors and hospitals. So both in India and foreign. In order to reduce the number of deaths because of heart disease, we have to predict whether a person is at the risk. Machine learning algorithm play a very important role in this area to develop the software can help to doctors to take decisions. So in this paper, we focused on how data mining and a data processing technique can be used to predict the heart disease in the advance. We're going to predict in advance such that patient is well treated. We use two different algorithms, the random forest algorithm for comparative analysis. But random forest algorithm has shown highest accuracy in the prediction. So we use the random forest machine learning algorithm supposed to predict the heart disease in advance. So our dataset contains here 303 samples and 14 features as well one output feature. So dataset is available and we can use this machine learning. We can train with 65 data training and 35% we have to test. So based on this condition, we are using the machine learning so accurate and prediction. So another is main GPS location information. When patient is in a minor, we will patient what doctor will monitor. But in the major condition, that time the hospital management will track the patient location and the system QRS value. Okay, the normal QRS value is in lead does not contain the Q wave actually. So only R wave and S wave, but the combination of the R wave and S wave is still referred to the QRS complex for the this lead. But the normal duration means interval of the QRS complex is between 0.08 and 0.10 seconds. So normally, but actually it's 80 to 100 milliseconds. So I calculated the 82 bit per minute. So it's an intermediate or slightly prolonged. The QRS duration of the greater than 0.2 seconds is considered abnormal. When the seconds goes on 0.12 seconds, we are going to predict it's an abnormal condition. This is our proposed system going to predict. So actually, as for requirement in this prototype, so we using the Raspberry Pi 3 B plus is advanced, and it takes the pulse input and the USB camera here, and the heartbeat sensor. It means pulse sensor, buzzer. We introduce the buzzer in the prototype because when a patient with a major condition, it will buzzer will high, so it can sort of alarm to the patient. Sometimes we slept in the night time, we can't recognize the heartbeat rate. So that we are introducing the buzzer and the USB camera. So main part of the USB camera is by the face detection of the patient and for monitor. So Android mobile, so we are using the Android mobile for the communication purpose, and everything is fed into the Android mobile. And GPS tracker for the major condition will while a patient is in a major condition, so hospital management so track them easily. And software requirement is the Python and OpenCV and Python script and Android Studio for the Android application creation. In the going to the implementation, so already I told the pulse sensor. So how actually worked? So using pulse sensor, ECG signal will collected and fed to the ECG. And main thing is how actually using the peak indices and the pulse sensor data, how we signals will extract. So using actually it's a raw ECG measurement. When we collect the pulse sensor data, it's actually in the raw format. So it is a rough information compressed by the ECG signal. So we are converted into the integrated ECG measurement with a QRS peak marked. It means without use of the template matching means the complex is classified because of every raw ECG contains the main contents and the extra features. So we only extract the Without template matching, we are extracting the integrated ECG measurement. This is actually original output from the raw ECG measurement conversation. The left figure shows that how actually first top of the signal is raw ECG measurement. When we convert it into raw ECG into filtered, then differentiate and squared and overhead, and below of the figure or signal is the our peak indices, and every in the PPT, so every point is the black because we are only concentrating on the QRS value from the raw data. So in the right side of the image figure will show that how actually QRS waveform will calculate and how actually amplitude and baseline we calculate in the raw ECG data. This is shown. And going to the next PPT. So in that we are discussing the how actually detecting the electrocardiography in the based on the number of the heartbeat selected before the threshold value, and each heartbeat QRS value given a abnormal ECG signal. So then we selected the only number of heartbeat. Okay, we are going to the accurate. So using the differentiated ECG measurement. So in that accurate and reliable ECG include extraction calculation is introduced. So along with a support vector machine. So support vector machine say in the machine learning algorithm. So coordinate the learning method using the three value. So ABC layer, we calculating the ABC along with the QRS form and for prediction purpose. So when we take the input from the USB camera, so it will going to the capturing the patient or person based face picture based on the image acquisition. When we got the data, we cannot see the patient name because sometimes the patient in the dark room, sometimes he is in outside. So we are converted into RGB color, and it's white and next converted into YCQR in the ambient light. So already discussed with how we actually implemented using the random forest algorithm, the disease and treatment, how analyzed by the machine learning algorithm. So when we capture the image from the USB camera, the image reprocessing is actually used for the quality of the image will enhance. Okay, it will remove the dark feature, and color feature extraction is used for identifying the text features. Sometimes face will be blur, and texture feature extraction is a dark skin image has different degrees of the plus texture that can be obtained as the energy, entropy, contrast, homogeneity, correlation, shaded feature. These are the equations. We let them train with a images, a lot of images and 3 node samples. When we convert it into ambient light. When going to the next slide, here how RGB color were into the ambient light because of grayscale channels. They will give the full shading features assembled in one time because of entropy. And texture equations already discussed last PPT I told. So energy, entropy, these two conditions for the full shading, and contrast homogeneity equations for the taking the RGB color equations. Correlation shade features we extract the background and only calculating the faces. When we taken these inputs and fed it to the cloud server using the GoDaddy servers and in this our paper, and calculate the whole time and predict it, and with the train with the 65 and 35% testing the data when server saved in a cloud server, it will helpful to the retrieve in an Android app. In our Android app, we are introduced the 3 dashboard: a patient dashboard, doctor, and hospital. In a patient dashboard, dashboard, we are multiple patients can log in, log out, and when we detect the face, will also it increasing. And doctor dashboard, it will show the patient number of patients and condition. And hospital dashboard, and interaction between patient doctor information fed into the hospital. When patient condition is measured, hospital management will track the patient with the information of the doctor. So as for the prototype, we are only predicting and analyzing the how we actually predicting. So based on the QRS complex, it's basically detect the raw data, and algorithm will be demonstrate the QRS complex heart rate. And QRS complex detected in a raw ECG data, algorithm will demonstrate with the ECG detector. And a waveform process with the use of the data, and band pass filter and derivative filter can implement the aim of the two QRS complexes. And main thing is calculate the time of incidence heart rate. It can be calculated from the time between normal range. So in this our prototype, we were only concentrating on first 3 seconds. Within the 3 seconds, we are going to predict, detect. After that, we will train with a detect. And second, with the camera model interface with the Raspberry Pi, image will be captured. And main thing is our aim is to track the patient's location is the main thing, because every doctor will contact with the patient. So you take the tablets and will do exercise. But the main aim is if a patient is in a major condition, hospital management can track the patient. So using the different technique used in the current system, so based on the IoT module. And actually, in this our prototype, you are in a first figure show that how actually heartbeat generated using the peak indices. And second is the patient condition. So in the patient application dashboard is showing the pulse rate. It's a 57.2, and actually as per condition, the 80 to 120 per minute it's a normal. The less or higher than 120, it's abnormal. So patient condition is abnormal, and sometimes if we wear the mask, or if we are sitting in the dark room, so it's detecting the face, not detecting condition will be predicting. So in this study, we proposed and implemented portable wearable ECG system for real-time heart attack decision with real-time tracking. So main conclusion is so aim of this paper is to accurate detection of the heart attack, and message will be sent to the patient, doctor, hospital in an emergency condition. So main thing. And heart rate and heartbeat are simply checking through the heart pulsation. Our contribution and is the entire smart system that provide real-time patient monitoring and displaying the heart rate. The proposed algorithm is a signal and face in color information. If this information will be fed to the machine learning, and that will predict the heart attack in the human being. So I'm referring there are the main Sir Chaudhary sir and Kasim sir papers and several papers. And main thing conclusion is going to the predict. So this is my actually presentation. And thank you for IoT and Intelligent App for 220, ma'am.
Thanks, Kripa Shagar, for a wonderful presentation. Next, we'll move on to next presentation. I will call upon Ms. Bai Nuresha for presenting her paper, Categorizing of Allium Sativum based on the Philippines National Standard Asian Standard using pixel per metric ratio and blob detection methods.
Hello, good afternoon. This is Baina Raja I Diploma. I am from Philippines. So I would like to present our paper entitled Categorizing of Allium Sativum based on the Philippines National Standard and Asian Standard using pixel per metric ratio and blob detection methods. Here are my co-authors, Dr. Arnold C. Paglinawan and Engineer Jesse R. Balbin. They are professors at Mapua University. Here's our abstract. The researchers used the blob detection and pixel per metric ratio methods to determine the texture and size of the garlic based on the Philippine national standards and Asian standard. The formulated blob percentage value in quality grading for extra class is less than 20% class 1 and is 20 to 40%, class 2 is greater than 40 to 60%, and the check is greater than 60%. The size of the garlic was categorized by class A, class B, class C, D, and class E. The functionality and reliability of the conveyor system were also examined in this study. So Philippines is one of the producers of the garlic in Asia. So we have in the Ilocos Norte, reported that can have shared 6,200 metric tons, Occidental Mindoro, and also in the Quezon province. In 2018, the garlic production in country was reported 7.6 thousand metric tons approximately. So sorting of garlic is necessary to check the good and the check before the delivery in the market. Usually, the texture of the garlic can be identified using manual method. So the main objective of this study is to develop a system that will classify the size and quality garlic based on the Philippine National Standard and Asian Standard. So this study can be achieved with the following specific objectives: to develop a hardware system that can detect the texture and size, to formulate blob percentage values that can categorize the garlic based on the local standard and Asian standard. The third is to test the functionality and reliability of the developed conveyor system. So this is our process. So here is the image of the garlic, and then we'll identify the texture, the grade A, B, C, and the recheck, and also the size. So the developed conveyor system can categorize based on the PNS and the ES. So here is the process in our image processing. So the garlic image filtering, color masking, then after that we do the pixel per metric ratio, and then color thresholding. Then the last is blob detection for the grading percentage value. So here is the sample of our grade A. Okay, the formulated percentage values of the blob are for texture analysis. The blob percentage value with less than 20% is grade A, or let's say extra class. The formulated percentage value of the blob, which is here, so we have the grade B, grade C. So for the grade B, we have 20 to 40%, and the grade C is 40 to 60%, and that is the class 2. So here's the recheck, the sample recheck. The percentage value with greater than 60% is a recheck category. So here is the tabulated. So we have the formulated percentage of the blob, at the same time the actual blob. So we check and it matched to our formulated grade percentage value of our blob. So here is the test result of garlic Asian standard. So the T, the manual and automation. So we use the T-test statistical method. So there is no significant difference between the manual quality grading and the automated quality grading. So therefore, so it means that the null hypothesis is accepted. So the manual quality grading is the same with the automated quality grading. So here is the conveyor. So conveyor that we have has width of 5 inches and a total length of 134 inches, which is made of synthetic leather. The conveyor has 6 beams designed for the class A, B, C, D, E, and the check. So each beam has IR sensor to detect if there is a garlic pass through to the beams. So once the sensor detects the garlic, the conveyor stops and load another garlic. We install the OpenCV and Anaconda to program the image processing in Raspberry Pi board. So for the SSH connection, the researchers use XME and PuTTY. In programming, it is important to establish the same baud rate for the serial communication of the Arduino and the Raspberry Pi. So all DC motors, IR sensors, and relays are functioning based on the program installed in Arduino board. So conclusions, here the conveyor system can classify the good garlic as grade A, as an extra class, grade B as class 1, grade C as class 2, based on the PNS, what we call Philippine National Standard, and the Asian Standard. It can also identify the recheck, the formulated blob percentage value for categories such as extra class, class 1, 2, and recheck were successfully examined. If the percentage value is less than 20%, the garlic disposition is grade A, and 20 to 40% is grade B, and the percentage with greater than 40 to 60 is grade C. So in the greater than 60% in the check category. So based on the test conducted, the formulated blob percentage were matched with the grade classification. So overall, the texture bulbs of garlic can be identified using the percentage values range as formulated in this study. So the functionality and reliability of the conveyor system were also checked from actual value to formulated value. So therefore, the objectives of the study were knit successfully. So these are our reference. So I would like to thank you. We would like to express our gratitude to our friends and our co-faculty members from Foray University, Jose Rizal University, from University of Makati here in Philippines, who give their utmost assistance towards the accomplishment of our work, and also the Elobotica, the robotics and automation solutions. So thank you for the opportunity to present our paper.
Thank you, Aisha.
Thank you.
Let's move on to next presentation. Ms. Rajeshwari and team. Ms. Rajeshwari and team, you can come forward to present your paper. Ms. Divya?
Yes, ma'am. Hello?
Yeah, you are ready for the presentation, no?
Yes, ma'am, we're ready. We
Yes,
just start
yes.
sharing the screen. Yes. Am I audible?
Audio and video is perfect now. You can go
Okay.
ahead.
Okay, sorry for earlier. So we are here to present a paper on the topic, automatic speech to sign language software to improve knowledge regarding brushing technique among speech and hearing impaired children. So we have done this project with a tie-up between the engineering and the dental school of Mysore, India. To start on with, there are about 63 million people in India who are suffering from hearing impairment. Children with such a condition are at a higher risk for language deficits and reduced cognitive skills due to communication barrier. One such risk is oral health hygiene. In oral health perspective, there ought to be under higher risk and magnitude, and the severity of oral health problems in these children are more than their healthy counterparts. Therefore, there is a need of oral hygiene education for such children. A mode of communication plays an important role in imparting education, and hence there is a need for professional modification of the ways of communication in educating these children. Oral hygiene education can be in the form of written instruction or visual media or any video output which is understandable by these children so that they can bridge the communication barrier. So we came up with an idea to design an automatic speech to sign language software which would help to increase the brushing technique among the children with hearing impairment. So this can be used by the children chairside, and the spoken instruction by the dentist or the doctor or the parent can be translated into the respective sign language which is displayed on the screen. So this model was also compared with a live demonstration of the same toothbrushing instructions. So using this automatic speech ASR system, a teeth brushing technique based on sequence learning principle is used to educate the children. As we know, it takes time to learn the sign language. So this system is going to be helpful for every doctor who has to communicate with the child on the bed who has to communicate. So to start on with the procedure, so first we have recorded these voices or the speeches of the words, and then we have sampled it at the rate of 8,000 hertz. So once we have recorded these voices, so we have chosen the native language in Kannada, and we have chosen a list of 82 words. So each word was repeated 5 times, and it was recorded across 15 speakers, out of which 7 were women. And once this was recorded, we removed the background noise and the silence so that we can extract certain important features. As we know that the machine cannot understand a real-time data, so it is necessary to extract certain important features out of this voice sample So we made use of feature extraction method. So the method which we have used is the LPC method. So this method gives us certain values which can be used to detect what kind of input signal is given. So we use these coefficients to train the neural network, and whenever there is a signal input signal coming in, based on the nearest correlation, we display the corresponding output and the image. So during the testing phase, the spoken word is recorded with the same sampling rate and the silence is removed, and it is compared against the trained speech features using neural network. So this is an example wherein you can see for the word. This is the corresponding sign language which will be displayed. You can see the recorded video for the same.
Ujjiri.
I hope it's audible. Was it audible?
This study was carried out in the Department of Pediatric and Preventive Dentistry at JSS Dental College, along with the Sairanga School for Speech and Hearing Impaired, Mysuru, India. There were 16 children who participated in this study, and they were all from the Sairanga School for Speech and Hearing Impaired. The children who were included were those who were newly admitted, who had not been taught this present method of toothbrushing, those of age group 6 to 8 years, those with moderate to severe hearing impairment, those that were trained in the regional sign language used by the teachers in the school, those who did not have hearing aids, and those who gave consent for participation. Children who were excluded was those who simultaneously had other disabilities and syndromes. These children were divided into two groups, where first group A was given education using this speech to sign language translation prototype, and the group B was given education using the live toothbrushing demonstration.
A self-designed questionnaire.
Before and after the intervention, the questionnaire was given to the children to assess their knowledge, and it was seen that all 16 participants demonstrated poor knowledge about frequency of brushing the teeth in a day, the motion of toothbrushing, and appropriate sequence of the technique. So before intervention, only 25% of these children had given correct responses to most of the questions. And there was a marked increase in the knowledge score of the participants after using this automatic translation software. These were the responses given by the children, which clearly shows that there was a significant difference in the number of children who correctly answered most of the questions using this software. In this present validation study, all subjects belong to an institute for rehabilitation of disabled children, yet their knowledge regarding brushing practices was poor. There was a marked improvement seen after using this newly developed software, and there is a need to give these instructions to these children in the way they learn best. So in order to facilitate better communication, family members, caregivers, and teachers should be encouraged to learn the correct means of maintaining oral hygiene and hence impart the same knowledge to the children more effectively. So it can be said that providing a suitable means for communication will positively influence the level of understanding in these children based on this brushing technique. Since this was the first time that the sign language translation software was used, it is apparent that the education and communication would be better when multiple sessions are done to make this learning more efficient. Within the limitations of the study, it can be concluded that this innovative automatic speech to sign language translation software was successful in significantly improving the knowledge regarding this sequence-based toothbrushing technique before and after instructions which were given using this software. This mode of education for hearing impaired children can be used by dental professionals to educate their patients, teachers to impart oral health education, and children themselves for self-learning. Thank you. Thank you, ma'am. What did she say?
Ms. Divya and team, thanks for the presentation. Next, I would like to invite
Yeah, thank you.
Mr. Sandeep to come forward to present his paper. Mr.
Yes, ma'am.
Sandeep?
Yes, ma'am. I'm there.
Yeah, you can.
I'm sharing the screen now. Thank you.
Yeah, sure.
Good afternoon, everyone. So is my screen visible to all?
Visible, your audio and video is perfect. You can go ahead, Mr. Sandeep.
Thank you, ma'am. So good afternoon, everyone. And thank you, first of all, for giving me this opportunity to present my research paper. So special thanks to IFERP and team. And my paper title is Implementation of Data Confidentiality in IoT Devices Using DES Algorithm. So myself, Sandeep KV, I am a research scholar and as well as assistant professor in the Department of Electronics and Communication, Ranjan Subhra College of Engineering, Bangalore, Karnataka. And this paper and my guide is Mr. Syed Abdul Hayan. He is associate professor in the Department of Electronics and Telecommunication in the Dayanand Sagar College of Engineering, Bangalore, Karnataka. So I will not take much time of yours, and I will move on to the contents, and then I will conclude the session very quickly. I will make it very smaller. So initially I will start with abstraction, then methodology. Then I will talk something about the tools that I have used, and I will show you the screenshots of results, and then conclude, and I can tell you what is the future scope that I am planning to, or somebody can think of it, and then we can conclude. So the abstract goes like this. Firstly, the title itself says confidentiality. So confidentiality is nothing but protecting the data from being accessed by some unauthorized parties. So if somebody tries to hack your data, or if somebody tries to manipulate the data, or takes your important information and tries to make use of it. So whenever we give protection for the data, that's nothing but confidentiality. So basically, sending data through IoT devices, they are prone to many kind of security threats. So whenever you are exchanging information among the devices, especially when it is connected to the internet, so there is no guarantee that your data is safe. So sending data through IoT devices are always prone to many kinds of security threats. So hence we apply the already existing tools only, that is DS encryption algorithm. So we are making use of DS encryption algorithm to the data at the transmitter side also. That means I'm using two devices. I will tell you what is that. So let me call now IoT transmitter. And first I will encrypt the data at IoT transmitter side. And the same is decrypted using DS decryption algorithm at the IoT receiver. So there is one IoT transmitter and IoT receiver. I am doing encryption at IoT transmitter side. And at the receiver side, after the data is been received or transmitted, I am doing decryption at the receiver side also. So by doing this, I can tell you some kind of a confidentiality will be achieved. So I'm using two Beagle bone blackboards that are used as IoT transmitters and receiver devices. So Beagle bone blackboards are readily available in the market. So I'm just taking those two devices and I'm calling one device as IoT transmitter and the second one will be IoT receiver. So when the communication starts among these transmitter and receiver, that is IoT devices, So here in my research, I'm just taken two examples, that is two devices. Like this, we can have more number of devices also. To check, I have started with two devices. So they start communicating with one another using IEEE 802.5 wired line standards. So that is nothing but our local area network only. So this is the communication protocol that I'm using here. And they uses client server mechanism for programming DS encryption and decryption communication purpose. And here Debian operating system, that is Debian OS, in both the BeagleBone boards are used. So Debian OS is actually one which supported by BeagleBone Black boards. So the first BeagleBoard, that is the one which I am taken as IoT transmitter, will encrypt the data first, will work as IoT transmitter and transmit the encrypt message. And the second device, that is BeagleBone Blackboard, will work as a IoT receiver and receive the decrypted message. So by this, that is the ciphertext will be converted to plain text. So I'll give you a small introduction about DS or triple DS algorithm. So this is a simple figure which explains about DS algorithm implementation for encryption purpose. So you can see the 64-bit plain text will have some initial permutation. So then they will be divided into right and left parts. So a figure here depicts the operation of DES having 64-bit plain text as the input. So this 64-bit input undergoes permutation. Then they split into right and left parts. The left and right parts are having encryption using 16 rounds with keys separately for the left as well as for the right parts. Then they are combined using the final permutation, and thus our 64-bit ciphertext is now ready for transmission. So just imagine all these are done. So we can confidently tell that there will be little chances of leaking the data. So by this 64-bit ciphertext, which is now ready for transmission, will be transmitted to the receiver, that is IoT device. Then the receiver IoT device has to decrypt it, and then it has to read the message using the provided keys. So 16 rounds of encryption will be done. So let us take an example. If the key is K1, so you can see in the figure, K1 is the key. And after the first round of encryption, let us say the data is now C1, that is ciphertext 1. Similarly, the second, that is the first round result C1 will undergo once again encryption with the key called K2, then the output will be C2. So like this, using the last key, that is K16, you will get C16. So this, after the final permutation, will go for 64-bit, that is the 64-bit ciphertext is now ready for transmission side. So this is about the DS algorithm. So because of all these advantages, I have selected this. Of course, there are AES algorithm and many other like DES or many other are there, but this was very high level of security, I thought, and I have selected this one. So let us see some, that is the hardware which I have spoken just now. So this hardware is a BeagleBone Black that is available in the market. And this BeagleBone Black boards are manufactured by Beagle Boards, and their processors are AM335X 1 gigahertz ARM processors, and they are of Cortex A8. And they have connectivity like a USB client for power and communication purpose, and there is a USB host, Ethernet cable facility, HDMI. So there is a 46 pin headers are there. So because of all these facility, so I felt this is the right one to select as uh, our transmitter and receivers. And they also support the Debian OS, which is used for me. And Android also supported. Ubuntu will be supported by this. So Cloud9, IDE. So all these are some of the libraries that are built in this BeagleBone Black. And the screen here tells us about the display of BeagleBone Black after the installation of Debian OS on it. So once the Debian OS is installed, so this is how our screen looks like. So this is the screen is ready, or the device is now ready for receiving the data or for transmitting the data. So this figure tells us how the connection, that is the LAN connection, IEEE 802.5 connection between IoT transmitter and receiver. So we can see the blue color wire is nothing but the LAN cable. So this is about the result part. So this is from the transmitter side. So this figure tells us DA's operational implementation using server client program and BeagleBone. So here, so the left section that is on the figure shows about the encryption key, which is 56-bit after reduction from 64-bit. So you might have remembered I have transmitted 64-bit ciphertext, but 56-bit will be that is reduced to 56-bit from 64. So the 64-bit key, which is used for our experiment, is, you can see on the screen, it is 0x1, 0x23, okay, like up to 0x EF. So the plain text which is fed to input of DS algorithm is same. That is the same 0x1, 0x23. This text is now fed. Okay, then this plain text is 64-bit long, and the ciphertext generated after DS operation is encrypted buffer. And in this experiment, it is 0x C9, 0x57, 0x44, 25, 6A, 5E, DE, and 1D. This is a 64-bit ciphertext which is generated by DS algorithm using 64-bit plain text. So let us see the next result. So this is a screen of the transmitter IoT device. So once the data is transmitted, so you can see the binding is now successful. And why the 16 rounds are required? Because 16 keys are required for us to transmit. So like key at round 1 will be 0x1, 0x23, and round 2 it will be 0x45, 0x67. So like this, it goes on up to 4 rounds. And after the 4 rounds, we can see on the screen, the transmitter and server has transmitted the same text, which is cipher, which is converted. So this screen shows the encryption key, which is 64-bit. So the 64-bit key, which is used for our experiment, which is just now I told, the plain text fed to the input of DS algorithm. So this plain text is 64-bit long, and the ciphertext which is generated after DS operation is encrypted buffer. And in this experiment, you can see that is 85 E8 1354 OF OA B4 and 05. This is a 64-bit ciphertext generated by DS algorithm. So let us see whether the same text will be received at the receiver or not. So once the data has been received successfully by the receiver, we can say the DS test will be successful. And if the same data is recovered using the same keys, then the test will be success. Or else if it fails, then the test is unsuccessful. So again, we have to do or resend the key, and then we have to check for the confidentiality. So this way we can tell that some level of confidentiality can be built. And the conclusion here is we could able to transmit the data from the IoT device transmitter using DS encryption, and we could able to receive it and decrypt it at IoT the receiver side. And the future work what we are thinking to do is we will now implement this DES using wireless technologies like Bluetooth and Wi-Fi. Now in our experiment, we have used local area network LAN cable, but in the future, we are thinking to do it wirelessly, that is by using Bluetooth stack and Wi-Fi by implementation of the same DES on the protocol stacks. So some kind of wireless communication we should do, that is we are planning for the next phase. And thank you for giving me this opportunity and sharing my knowledge. Thank you one and all.
Thank you, Mr. Sandeep. Next, I would like to call upon Mr. Ankur Sherawat to come forward to present his paper.
So, Am I audible, ma'am?
Mr. Ankur Shirabar?
Yeah. Am I audible, ma'am?
Yeah, you can start sharing your screen.
Yeah. Is it visible?
Yeah, you can go ahead.
Okay. Good afternoon, all. So, topic of my research paper is secure authentication of IoT devices and smart cities.
Mr. Ankur, your voice is low. Could you make it a little bit louder?
Is it audible now?
Yeah.
Yeah. So, good afternoon, all. Topic of my research paper is secure authentication of IoT devices in smart cities. The abstract of my research paper is a smart city is a concept which helps in cultivating human life by collecting and processing the data shared by the user for future prediction and advanced planning. A smart city consists of various systems which helps in accumulating and analyzing the data like IoT sensors, mobile devices, and other computing devices.
Mr. Ankur,
Therefore,
sorry for the interruption. Please check your mic. Your audio is very low.
is it audible now?
Yeah, it's decreasing gradually.
Okay. So, a smart city is a concept which helps in cultivating human life by collecting and processing the data shared by the user for future prediction and advanced planning. A smart city consists of various systems which helps in accumulating and analyzing the data like IoT sensors, mobile devices, and other computing devices. Therefore, a secure communication channel between the smart entities is very important to protect data from cyber criminals. So, our aim is to provide an efficient security protocol with authentication and key management system which gives negligible delay in the real-time environment. So basically now what is a smart city? Well, smart city is a framework predominantly composed of information and communication technologies to develop, deploy and promote sustainable development practices to address growing urbanization challenges. A big part of ICT framework is essentially an intelligent network of connected objects and machines that transmit data using wireless technology and the cloud. So cloud-based IoT applications receive, analyze and manages data in real time to help enterprises and citizens make better decisions and improve quality of life. Why do we need smart cities? As urbanization is a non-ending phenomenon. Today, 54% of people worldwide lives in cities, a proportion that's expected to reach 66% by 2050. Environmental, social, and economic sustainability is a must to keep pace with the rapid expansion that is taxing our cities' sources. Introduction to the framework of the smart cities. Well, smart city uses a framework which has high technology like information and communication technology, internet of things, IoT and logistic to improve the lifestyle of the citizens. Smart city consists mainly three things: the user, remote smart system and an intelligent city building. Thousands of IoT sensors are used to collect data from the remote smart systems RSS and send it to the center city server to make a smart decision related to the city as shown in the figure. All the city data is stored on internet without any security and authentication. It may become very easy for hackers to attack on city data which is harmful for the citizens' life and for the nation as well. We devise an efficient authentication and key management model to secure the communication between the smart city entities. The major challenge for smart city is a secure communication process by providing security verification and authentication between the users, smart systems, and the central city's server. Objective of our paper is that to make a secure communication protocol between the smart city entities to provide an authentication system and a key exchange system for data privacy. Now, in our authentication and key management model, every remote smart system and citizen have to be registered through secure registration phase. After that, some private keys are generated and shared among the smart city entities. That keys are used in secure communication. This key is generated through AKM service as shown in the figure. The protocol is capable of parallel processing with an efficient secure communication mechanism that makes it possible to work in real-time environments, and this proposed model is evaluated in terms of its efficiency and capability to operate in real-time environment. So our proposed protocol majorly consists of four phases: a registration phase, key exchange phase, session key revocation phase, and data transmission phase. So in registration phase, during the registration phase, the data in ICB is very crucial through therefore before communicating with ICB, RSS and user has to be registered on an entity called city registration service. The RSS user has to send the required information to CRS with some information. Here, CRS is central city server, whereas CRS verifies the request and registers it, and in return, it provides a stamp identity. Later, the stamped information is used by the remote city entities to get authenticated by ICB. In key exchange phase, for both entities are RSS and intelligent city building, the process of key exchange is similar. Here we use a symmetric system for the encryption and decryption of the data by sharing the security key among the communication parties. Firstly, the ID and stamp is encrypted by the sending entity with the ICB's public key, and then the timestamp and then timestamp is generated. After that, hash of the encrypted message is signed by the sending entity with its own private key, and it is sent to ICB, whereas ICB validates the signature and the stamp. After the verification process, secret seed value and a shared key are generated by ICB. Both of the parameters are further encrypted and signed by the ICB and sent back to RSS. The received information is verified and authenticated again by RSS. So the session key revocation phase, in the use of session key is limited for a particular time period. After that, key revocation and session key exchange is carried out again. Key revocation method is carried out when any of the keys is compromised due to some reasons. For session key refreshment, the key revocation process is quite similar to the key exchange process, but here is no need of remote entities to send their ID stamps and public key. In data transmission from remote system, after the key exchange, ICB holds a share key called K, the seed of RSS, SDRSS, and the seed of ICB, SDICB. Using these secret seeds, messages can be transmitted securely between them. Now, if the data transmission is from user to the main server, the communication between user and ICB is done infrequently. Therefore, the system has delay tolerance and need more security. For providing more security, we will use a symmetric block cipher for encryption, PKC for signature, and hash function for integrity. The data is encrypted by K, and uh, the key which is shared, and the signature is taken on the hash digest on the message. The reverse process is performed on the reverse end. So the conclusion of our paper is that a brief information of smart city and focusing on the privacy, security, and many threats due to which smart city facing the problems. The major problem for the smart city is communication between the smart city entities, which is not secure. So we proposed a protocol which provides security and it secures the data of smart city which is on the internet and makes communication more secure. These are the some references which we took for our paper. So thank you all for listening to my presentation. Thank you so much.
Thank you. Thank you, Mr. Ankush Rabat. Next, we come to the end of the session, technical session. So we are going to wind up the conference now with vote of thanks. So I thank each and everyone who participated in the conference and shared his wonderful presentations, innovative presentations on their research papers. So even we are looking forward to extend your support in future conferences also. And at the same time, we came to know about so many innovative things today and thank for that. And we apologize for the network issue what happened here because of rainy conditions here in Tamil Nadu. We faced the network issue. I apologize for that. So let me wind up the session. Thanks each and everyone who participated in the conference. And at the last, I thank our organizing team and our honorable note, everyone who extend their valuable support for the conference. Thank you.